This video covers Pre-Calc Notes 2.1. We're going to be talking about quadratic functions, and quadratic functions are those that are of degree 2. So let's take a look at a bunch of different equations here, and like I said, most of what we're going to be doing is looking at degree 2 polynomials, which we specifically call quadratic functions. So if I have something like this, f of x equals a, if I plug in a number for a, we would say maybe f of x equals 2, then that is just a line. And we would say that this would be considered degree 0 because there is no exponent at all, and there is no variable either, so that's why there can't be an exponent. When I look at the next type of equations that we've looked at or even graphed in the past would be something like this, an ax plus a b. You'd probably see it more likely in the form of y equals 2x plus 1. Again, that's going to be another line. This time it will have a slope. It won't be either horizontal or vertical like this one. But this is considered degree 1 because the exponent that is with my x here is an imaginary 1. What we're going to be looking at today are these degree 2 polynomials, which we call quadratics. It's called degree 2 because we have the squared here. Okay, so this is the generic form a times x squared plus b times x plus c, and if I plug some numbers in for a, b, and c, we'd get 3x squared plus 2x plus 1. And we'll eventually get to the point where we are graphing degree 3 or degree 4, degree 5 polynomials. So here's the generic form of it. Here's one with some specific numbers in for a, b, c, and d. This is degree 3 because the highest exponent is 3. So that's how you tell what the degree is. It's the highest exponent value. And like I said, we're going to be focusing mostly on, in this section, graphing quadratics. So let's take a look at an example of that. So if we have the graph -2 times x minus 3 squared minus 1, and in our previous chapters we talked about the generic or the parent functions of these graphs. In this case would just be an x squared. Well, here's what I know about an x squared. It had a vertex at 0, 0, and then it formed a parabola that looked something like this. So I'm just going to make a dashed one on here so I can get the idea of what this graph looks like. So this is the parent function. And we talked a lot in the last chapter about the impact that the numbers that I add into my problem, what they will have on my graph. So let's first talk about this -3 here. What this -3 will do is it will end up shifting my vertex, which right now is at 0, 0. It will shift my vertex opposite direction, so left or right. So if this is -3, it's really going to move it right 3. This -1 will move my vertex up and down, and so a -1 is going to move it down 1. So I can take this from 0, 0, move it right 1, 2, 3, and down 1, and that should be my vertex of the graph. So the vertex of the graph is positive 3, -1. Sometimes we'll label this vertex as an h, k value also. Then let's take a look at the -2. First of all, I know that if it's negative, it's going to be a reflection. And that reflection is going to be along the x-axis. And because this is a 2, what it's going to do is it's going to make my graph be skinnier. So my graph is going to be skinnier than this, and it's going to be opening downward, so it's going to look something like this. And all of our degree 2 polynomials, when we graph them, are going to be this parabola shape. Whether it opens up or down is based upon the fact whether this a value that's out in front here is positive or negative. In this case, it's negative. Now this is this form that we're looking at. This is called vertex form. We don't always have our equations in this vertex form. Sometimes we have it in standard form. So that's the next concept that I want to talk about, is what is the difference between vertex form and standard form. So let's take a look at that. And I just realized I was calling it vertex versus standard form. It's really standard form and vertex form are the same thing. So standard and vertex form are the same thing. It's expanded form. So it's standard form versus expanded form, or vertex form versus expanded form. Vertex form is what we just looked at. So the generic way that we would write this equation would be y equals a times x minus h quantity squared plus k. And we recognize that the numbers here and here, so the h and the k, that's my vertex. Okay, so that shouldn't be anything new. Expanded form is when we actually take the time to FOIL this binomial, multiply in the a, and then combine the k with its like term. So you'd end up getting ax squared plus bx plus c. Okay, that's the expanded form. Now sometimes you're going to get this, you'd be given this form, and what's nice about the standard form or the vertex form is you can pull the vertex out right away. If we're trying to look at the expanded form, the only way that I can pull the vertex out of there is to use the vertex formula, which we'll get to a little bit later in the notes. And so I can see a lot of shifts that are occurring when my equation is in this form. The shifts are not nearly as obvious when it's in expanded form. So let's work going back and forth between each of the two forms. So right now I'm in vertex form. So this is vertex form, which they also call standard form. And I want it to go to expanded form. So I want my problem to be ax squared plus bx plus c. So all I have to do is follow order of operations. FOIL that first. So x minus 3 times x minus 3 would give me x squared minus a 3x and another 3x and plus 9. So when I combine like terms, I get that. But now I need to go and bring down the negative 2. So the negative 2 is being times by all of that. And then I'm subtracting 1 from that. So my next step would be to distribute the negative 2 into my problem. Do it to all three of these. This would make a positive 12x and a negative 18. Bring down the minus 1. And then the only place that we have some like terms would be right here. Minus 19. Now you'll notice that this original problem was started off as an f of x, and I wrote this as a y over here. You can interchange the f of x and the y, but if they do write an f of x here, you should probably label it back as an f of x instead of putting it as the y. So this would be the expanded form of this graph. If you were to take the time to graph this and this equation, either one of these equations, they should be exactly the same. But again, what's nice about this form is that you know what's happened to the parent function. You can talk about the shifts, and you can talk about if it's reflected or not. And you can also identify what the vertex is right away. And those changes aren't as obvious when it's in this form here. Okay, looking at the next problem, now I've got a function labeled g. So g of x is equal to x squared plus 8x plus 11. And I want to go from this expanded form into standard form. And so this is my my form. So what I need to do to be able to get into this form is I need to remember how to complete the square. So that's what we're going to talk about here. Okay. So the first thing that I want to do when I complete the square is I want to group all my x's together. So I'm going to group x squared plus 8x plus some blank. I'm going to group all those together. And then I'm going to choose to move any non-x terms over to the other side of the problem. So I would have to move this over. So this would be negative 11 equals that. And remember that this g of x is really over here. We're just going to ignore it for right now and just deal with focusing on completing the square. And then we'll go back and put our g of x back into our problem in just a moment. So here's the process that I need to do. I need to figure out what number can I put in this blank that's going to make this become a perfect square so I can get this x minus h quantity squared. So the process would be I take half of the b value. In this case, this is my b value, so I take half of 8. I get 4. And then I square that to get 16. So 16 is what I put in the blank here. And to balance out my equation, I can't just put 16 here because then I've changed the problem. I also need to put a blank on this side of the problem and put a 16. So I balance the equation by putting 16 on both sides. So therefore, I haven't just added 16 to my problem and expect it to be the exact same equation, because it wouldn't be. Okay, so I specifically wrote this out because once you write this out, whatever this number is right here, this will be the number that it becomes my h value in terms of this x minus h. So this side of my problem would give me a 5. This would become, I could factor this down, I can say what multiplies to be 16 and adds to be 8, and it would be 4 and 4, but again I already have that number right here. So I'd write it as x plus 4. And the reason it's plus and not minus like it is up here is that was a positive number. If this would have been a negative number from my problem, then I'd put a negative 4 in the blank. And then I can put my squared in there. So this is what my problem would look like, and so now what I'd want to do to make it so that it balances back out into this form here is move this number back over to the other side. So subtract 5, and so now I can say that g of x is equal to x plus 4, that quantity squared, minus the 5. And now I can go through and I can list out what my a value is, what my h value is, and what my k value is. So let's do that. I know that my vertex hk is a negative 4 because it's supposed to be a minus here. So it'd be a minus 4 and a minus 5. So if we take the time to graph this, we go over 1, 2, 3, 4. We go down 1, 2, 3, 4, 5. I know my a value is a positive 1. There's an imaginary 1 right here. So that means it's going to open upward. And my graph would look like this. I don't know why I'm making a dash. I should make that solid. So my graph would look like that. Now, if I was just asking you to find the vertex of this, okay, let's just change the problem up a little bit. You don't have to go through and complete the square, do all of this work to be able to find just the vertex. Recognize that you can find the vertex by just, by completing the square and pulling out the hk value, but when it's in this form, how do you find the vertex? Well, the way that you would find the vertex is you use this equation, x equals negative b over 2a. So I'm going to highlight that because that's a formula that you want to know. So when you have your equation in expanded form, you can find the vertex. Let's do that with this problem here just so we can see that we get the same answer when we do this. And I'm also just going to change this g of x to a y just to make it a little bit easier because we're really writing this as an x comma y value. So remember that expanded form is ax squared plus bx plus c. So if I write my formula out, x equals b is 8, so it says negative b, over 2 times a is an imaginary 1. This becomes negative 8 over 2, and that becomes negative 4. And again, remember we had our x value, or the h value that we called it, was a negative 4, and so we get that also for our vertex. Then to find this k value, or more specifically for ours, the y value, we just plug a negative 4 in. We would say y is equal to negative 4 squared plus 8 times negative 4 plus 11. This becomes 16 minus 32 plus 11. Negative 16 plus 11 would end up giving me a negative 5. And so then I get the y value to be negative 5. So if I write that as an x comma y value, it would be negative 4 was my x, negative 5 is my y. So that's another way that I can get my vertex. So you don't have to have it in vertex form, like this, to be able to find the vertex.